Hi math students, this is Mrs. B and I am back to talk about piecewise defined functions. A piecewise defined function is a way of writing multiple functions, each with its own restriction on domain simultaneously. So basically there are different rules for the domain. If x falls into a certain category, then you're going to use this rule in this piece of the function. One function has multiple pieces or outputs, which are controlled by different constraints. A constraint is a restriction or limit on the domain, which is the x values or the inputs. It's a rule or a boundary. Each piece of the function has its own domain. Take a moment to screenshot this page or pause it to take notes. I'm going to move on to the first example. So given this piecewise function, let's evaluate these two examples here. So here's the function, and here are the three pieces. So there are three pieces here, and then here are the rules, or the constraints. So, as you already know, this number within the parentheses, that is your x coordinate, right? That's your x value. And so, whatever this x value is, you're looking to see for which rule will it fit. So, x, for the first example A, it says x is -9. So where would this -9 fit? Is -9 going to fit here where x is less than -3? Will -9 fit here where x is between -3 and +9? Or will that -9 fit here where x is greater than 9? -9 will fall into this first category where x is less than -3. So we're going to use that first piece to evaluate f of -9. So this function tells us to do x plus 1. So we're going to do -9 plus 1. So f of -9 equals -8. And we do the same thing for b. They give us the x coordinate of -3. So this is our x coordinate. So which piece of the function should we use to graph -3 or to evaluate f of -3? Is x equals -3? Is it less than -3? Is it greater than or equal to -3 but less than 9? Or is it greater or equal to 9? It falls into this category here. And this rule states that if x falls into the second category, then the function will just equal 5. So there's nothing to solve there. So no matter what x is, if it falls into that second category, y will always be 5. Okay, here's an example where we can apply the same logic and also graph our piecewise function. So here we have two pieces and two constraints. So we'll make a table of values for each piece. And I've done that here. And I've listed the two pieces and their corresponding restraints. So you pick x coordinates to plug in to your table and using the rules you saw for y. So let's do this blue piece first. The rule is x has to be less than 3. Now, we are going to start with x equals 3 because when we go to graph this, we'll use an open circle to show that we're not including 3. See, it's less than, strictly less than. So we're not going to include 3, but we have to start with 3 so our graph has a starting point. You'll see what I mean when we graph it. But we're going to start with x equals 3. If x equals 3, what is y? We'll just substitute 3 into x and solve. Negative 1/2 times 3 plus 2. I'll give you a second. Y will equal 1. Now, continue to choose x values that are less than 3. So you could choose 2, 1, 0, -1, -2, -3, -4, whatever you want to choose. It just has to be less than 3. I like to work easy, so I'm going to choose 0. If x is 0 and we substitute it into this piece of our function, we will find that y equals 2. Feel free to pause the video to take a moment for you to choose your own x and solve for y. I'm going to continue. I'm going to choose a negative number, so I'm going to choose -3. If I choose x as -3 and substitute it into our piece, we will find that y equals +3. So now let's graph this. This is a linear function, so it's going to be a straight line. We know it's linear because there are no exponents on our variable. So I'm going to draw a straight line connecting these 3 ordered pairs. I'm going to start with 3, 1. So 1, 2, 3, up 1. And I'm going to use an open circle to show that although I'm starting here, we are not including this point. My next ordered pair is 0, 2. So 0, up 2, and then -3, 3. 1, 2, 3, up 3. Use a straight edge or a ruler to connect your dots, and there's our linear equation. Now let's graph the red graph. So the rule here is that x can start at 3, because you see here it says or equal to, but x also has to be greater than 3. So again, I'm going to start with 3, and if you use 3 into this red piece of the function, you'll see 3 minus 5 will give us -2. Now you take a moment to pause this video to choose any x coordinates that are larger than 3, because that is the rule. The rule says to choose x's that are larger than 3. And you substitute them into this function and solve for y. I'm going to continue choosing x to be 4, and then y will be -1. And then I'm going to choose y to be 5, and I will see that x to be 5, and then I will see that y is 0. So now let's graph this linear function. So the first ordered pair is 3, -2. So I'm going to go right 3, down 2. And I'm going to use a closed circle because it is included in this graph, hence the or equal sign. The next ordered pair is 4, -1. And then 5, 0. Connect your dots, and you can see there's our piecewise function. Let's practice finding our domain and range. The domain will be the x values from left to right. So let's look at our graph from left to right, from -infinity to +infinity. You can see our graph does start with -infinity because it continuously starts in the far left area with the arrow, so it means it's going to -infinity, right? So our domain is -infinity, and it continues forever in the right direction. So that's going to be to +infinity. Now some of you may be questioning, what about this hole? Well, although there's a hole here at 3, do you see it is covered here. So although that hole is there at -3, at +3, that's a +3. Although there is a hole here at +3, it is picked up here, so it's covered. So there are no holes in our domain as far as our domain is covered. There's no holes on our x-axis. The range starts from the bottom, and you want to see how far our graph goes to the top. So, what is the lowest point of our graph? It's here. So this ordered pair is +3, -2. So the y-coordinate is -2. So the lowest point is -2, and it is included. And it goes up, 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 up forever. Again, if you're looking at this hole here, yes, there is a hole there, but do you see it is picked up here? It's included in this graph here. So there are no holes in the vertical aspect of our graph. Lastly, this would be a good opportunity to find a relative extrema. Do you see we have a relative minimum here? So we can say the min is the y-coordinate at the x-coordinate. It occurs at the x-coordinate. To wrap up piecewise functions, let's graph one more. So here you see we have 3 pieces to this function and 3 constraints. So what we can do here is create a chart for all 3 of these pieces. This is going to be x minus 1 for x is less than or equal to -3. This is going to be -1 for x is between -3 and 4. And then we have 1/2 x for x is greater than 4. Pause this video and take a moment to attempt this one on your own. Remember that you must start or at least include the given points for the constraints. So for the first one, you want to start with -3. And then the rest of the x's you choose must fit that rule. And so for the blue piece, it's going to be x has to be less than or equal to -3. Take a moment to pause this video and complete this chart. If you started with x is -3, for the blue piece, you would have found that y equals 4. Continuing to choose x values that are less than -3, I'm going to choose x as -4. And then I will find that y is -5. And then lastly, I'm going to choose x as -5, and I'll find that x is -5, then y is -6. So for the purple piece, x has to be between -3 and +4. So again, we're going to have to choose that starting point of -3. When we graph this, it will be an open circle, not a closed circle, because you can see it is strictly less than. If you choose x as -3, then you will find that y will be -1. And now choose x-coordinates that fall between -3 and 4, because that's what this rule says. It says x has to be between -3 and 4. So choose